That's enough of that. All right, we got some fun stuff to look at today. So, story time. I had a rooftop unit, circuit breaker inside the unit. Fan motor died. Circuit breaker is tripped. Right? No big deal. Replace the fan motor. Turn the thing on. Guess what? No power. Fuck. So, reset the breaker downstairs. Go back upstairs. Turn the thing on. Boom! Big flash of electricity. Fuck, I wish I was recording. So, the fan motor died. The unit tried to mechanically cool with a dead fan motor in winter. So I had one contactor do a little blowy uppy. Yeah, you see that? Oh, can you smell it through the screen? So that thing blew the fuck up. The mechanical cooling is disconnected, but the heating is there. For now, I'll look at it again in spring. So, replace that thing, right? Turn it on. Check for power. Well, I got no low voltage. Oh, fuck me. Here's the 600 volt to 24 volt transformer. We're toasty. That thing's fucked. Cool. So we got two things dead. And I haven't even turned on the new motor to see what the fuck's going on. So, get the transformer replaced. Turn it on. No flashes. Voltage stops at my board. The fuse is popped in the board. Replace the fuse, try again. This second stage cooling contactor tries to pull in, pops the fuse. So I'm curious to see, there's no burnies here or here, but our low voltage is what's missing here. So we're gonna take this apart and teach a little bit about a contactor, how it works. And we're gonna take apart this motor because it's rather spectacular. That was a blue wing nut, right? These were blue. These are melted together. Look, can you see in there? Like, shit went down, man. So I'm excited to take this one apart. But let's start with the simple shit. Contactor, how does it work? A contactor can have a low voltage of 24 volt, 120 volt, or 208 volt to go through this bottom portion here. Underneath here is a coil. Electricity goes through there, it pulls a plunger. Pulls a plunger which pulls this in. There's electricity waiting right here. As soon as this gets pulled in, electricity then goes out to whatever the load is. Could be a compressor, could be a motor. So let's take this top bit off and take a look at the contacts of the failed guy here. Doesn't seem to want to focus, but oh, there you go. You can see it's supposed to connect like that. So this gets pulled down. Voltage goes through the bottom here, the coil, which pulls this down like a solenoid, like a plunger, and connects this power to that side. It's not supposed to be that dark. It's supposed to be brassy like that piece. But my problem was on the coil here, so I kind of want to see what the underside looks like. If you ever want to quickly test one of these, by the way, let's look at. This is the guy that burnt up top. This is the guy that burnt in the coil. Let's do some voltmeter readings between the coils. Take a meter that has resistance in ohms. Put them together, right? Darn near 0 ohms is like a wire. We want there to be some sort of resistance in the coil underneath here. So we'll take the one that we know has a bad coil out, and we'll measure the one that I think has a good coil between here and here in ohms. We have about 10 ohms. We can't really do direct math because it is an inductive circuit. It's not a resistive circuit because it has a coil. I can't just say that 24 volts divided by the 10 ohms is exactly how much amps this will pull. It doesn't work like that. However, so this one had 10 ohms, right? This one, the one that was popping our low voltage fuse, our 24 volt fuse, it's almost like it's shorted underneath there. It's the same as doing this, right? Almost 0 ohms will be a dead short. Now, let's see what that coil looks like. take off the bottom. I think these ones, yeah, have these weird side things. And then it should... Look at that. There's your problem. It should just slide right out. Yeah, there we go. That's cool. So there's a spring on here that pushes the other side of this coil up. So there's your problem. We melted there. Can you smell it through the screen? I can smell it through. When you let the smoke out of the electricity, it doesn't work no more. So what happens is power goes through here, through this coil down here, creates an inductive field on this magnet, pulls it down, right? So when it sucks it down, big power goes through. Right, so yeah. There's our problem with that, hey? I think that's pretty cool. Loud noises! This motherfucker here is very interesting. The back is all burnt up. All the wires are absolutely fucked. These morettes used to be blue. Heavily overheated. The front does spin, but it makes a grinding sound. I can see through these slats, and I think I know kind of what happened. How it happened, I don't know. But I'm excited to pull it apart and show everybody. So on these motors, there's 1, 2, 3, 4 long bolts that go all the way through. I'm going to take these bolts out, take the end bells off, and take a look inside. Bolts. A little flat blade and give it some love. Wow, okay. Interesting. This is the exciting side. Let's do the front side first. Okay, so I gotta somehow get you in here. There we go. You see that? This is the shaft, right? It should be attached to a rotor inside. The rotor inside, she don't move no more. She don't move no more. Crazy, right? So this piece has totally sheared off of that piece. Isn't that crazy? I think that's crazy. On the back side, there's the rotor. Like what? And then this is supposed to be a fan on the back, maybe? It's totally melted. Just break that shit off. Bearing's still okay. Yeah, so this here, totally sheared off of that. This is usually going to be one piece, and you have to tap this off of the... This is the stator, where the magnetic field is induced to make the rotor rotate. And no, it's not supposed to look black like that. Crazy, hey? Never, ever seen that. That is absolutely bonkers.